In this video, we're looking at finding the inverse function for functions that are a bit more complicated than we saw in video 1. Before continuing with this video, you need to make sure you are comfortable answering the following types of question. So pause the video and have a go at these. For the first one, you should have found that inverse f of x would be x minus 2 over 3. Now, if you're not sure about how to do this kind of thing, you need to go back to video number 1. For the second question, you should have found that x equals 5y over y minus 2. If you weren't sure about how to do this one, you need to go back to topic A5a, part 3 in particular. But you might need to go back a bit further to part 1 and part 2 of A5a if you need to build up to doing questions like this. Just before we dive into this video's main example, we need to recap one main idea from the previous video. And that is that if you've got a function f of x and you use that as the input into inverse f of x, then you will simply get x. That's saying that inverse f of x is just x. Inverse f effectively undoes the effect of f. So when they are right next to each other like this, they effectively cancel each other out. Remember, what this actually means is that we've got inverse f of x. So we're using f of x as the input into inverse f in this particular case, and by doing this we end up getting just x. And notice that this is also true if we wrote them the other way around. If I had f of inverse f of x, I would still get just x. So that's a big idea from the previous video. Again, if you need to recap, go back and watch video number 1. If you're happy with all of this, then stick with me and we will look at this video's main example. Here's the question. Given that f of x equals x over x plus 3, find inverse f of x. Now, in this particular case, we can't really use the system that we used in the previous video. We can't really start off with x and think in terms of a flowchart. So what are we doing to x? Well, what we're doing to x is dividing it by itself plus 3. The problem is that x appears in 2 places. So we can't really work our way through to some output and then try working backwards as we did in the previous video. So we're going to do something different instead. I'm going to start by saying let y equal f of x. Now, the only reason I'm doing this is because f of x is a bit of a pain to write compared to just y. Now, what this means is because y equals f of x and f of x equals x over x plus 3, I can write y equals x over x plus 3. What I'm going to do next is rearrange this to make x the subject. Now I'll explain why we do that at the end. So first we just need to rearrange this to make x the subject. I can do that by multiplying the left and the right hand side by this denominator. So that will give me y lots of x plus 3 on the left. And on the right hand side, I'm just going to have x. Because remember, I multiplied both sides by x plus 3. And if I had x divided by x plus 3, but then multiplied by x plus 3, it undoes the effect of dividing by x plus 3. So now I've got y multiplied by x plus 3 equals x. I can expand the left-hand side. So that gives me xy plus 3y, and that equals x. Next, what I need to do is collect the x's onto one side of the equation. So I'm going to subtract an x off the right-hand side and therefore off the left-hand side as well. So that would give me xy plus 3y minus x, and that will leave me with 0 on the right-hand side. And what I also want to do is remove any terms on this side that don't contain an x. So I need to subtract 3y here. So that leaves me with xy minus x equals negative 3y. We're almost there. Remember, what we're trying to do is make x the subject of the formula. The problem we've got is that the x appears in more than one place. But by doing everything we've done so far, we're now in a position to factorize the left-hand side. So I could rewrite xy minus x as x lots of y minus 1. And that equals negative 3y. And the final step then would be to say that x equals negative 3y over y minus 1. Now let's just take a breather for a moment and go back to what we said at the beginning. We deliberately chose to let y equal f of x. So if we've got y and that equals f of x, then what I can do is take the inverse f of y and the inverse f of x. So essentially what I'm saying is that we do this. Inverse f of y is going to be inverse f of x. And I could put brackets around here, but remember, I don't really need to if you remember our function notation. Anyway, the point is, inverse f of y equals inverse f of x. But remember our big idea from about 4 minutes ago. Inverse f of x is just x. These functions cancel each other out in effect. So what we can say here is that inverse f of y, that's just going to equal x. Now, using this little fact here, that inverse f of y equals x, what I can do is change this x here into inverse f of y, because it's equal, it's the same thing. So I'm now going to rewrite this as inverse f of y, and that equals negative 3y over y minus 1. And we are pretty much done. All this is telling us is that the inverse function takes the input, and you do negative 3 lots of that input divided by that same input minus 1. Now, this gives us all the information we need about inverse f, this function that we were looking for, but it's conventional when we define a function to use just an input of x. And in fact, the question even asked us to find inverse f of x. So all we do is, instead of having an input of y, we have an input of x. And that just means we can say inverse f of x, that equals negative 3x over x minus 1. Remember, it doesn't really matter what's inside the brackets as long as you understand that that is the input into the function. So inverse f of y is negative 3y over y minus 1. Inverse f of x is just going to be the same thing but with an x instead. It's negative 3x over x minus 1. When you're doing questions like this for yourself, you don't really need to do this bit up here every time. It's just something to have in your head. And in fact, when you've rearranged your formula to make x the subject, what your teacher might have told you is simply take this expression here and change the y's into x's. And that then gives you your inverse f of x. So you can leave out this line of working. But hopefully by showing it here, you understand why it makes sense to swap those y's for x's.